Good morning, this is your Stat Sensei, Mr. Spensei, and this is a warm-up on confidence intervals. Our scenario is say ah. So a large urgent care network prescribes the same antibiotic to more than 9,000 adult patients each year for uncomplicated strep throat. You take a simple random sample, SRS, so we have a simple random sample of 41. That's going to be important because that tells us our sample size. So our sample size in this case is 41. Who completed the prescription and record the time in hours until their sore throat symptoms noticeably improve and are able to swallow comfortably. The sample means time is 29.4. So here we have the sample mean. So this means we have X bar equaling to 29.4. Assume the population standard deviation is 10.2. So we have 10.2, and we're using this symbol to represent our population standard deviation. Calculate a 96% confidence interval for the mean time to noticeable improvement for all students and interpret the confidence level. Well, the very first thing it asks for is our formula, which is simply X bar plus or minus Z star standard deviation divided by square root of N. Well, the nice thing about that is we have X bar, we have this, the standard deviation of the population, and we have N. So the only thing we're missing is Z star. So there's our X bar, there's our N, there's our standard deviation of 10.2, and here's our confidence level. Now, the one thing we need to calculate is our Z star, because we said, hey, we have everything but Z star, so how do I do that? Well, first off, I should probably draw myself a little picture of this. And the little picture goes something like this. We're going to be centered at X bar, which in this case is 29.4. And we know the mean for all Z's is 0. And that's what really what I care about is 0. And I want this area in here to be 0.96. So to do that, I'm going to do an inverse norm, second vars, inverse norm, area. Now, there's several different ways to do this. Since we have the center, this calculator has a center, we can just put in 0.96 as it shows up, mean is 0, standard deviation of 1, and we can press center. When we do that, we end up getting a Z star of negative 2.053 to positive 2.053. Now, really, all we need is the positive because we're positive people. So in this case, Z star is 2.053. And we've already said that this is going to look like our picture here, where we're centered on an X bar. And we're going to be looking for this lower value and this upper value. So at this point, we can go ahead and plug in. We're going to plug in 29.4 for the X bar. We're going to plug in the 2.0537 for the Z star. We're going to plug in 10.2 for our standard deviation, and we're going to plug in 41. All right, at this point, we're ready to go ahead and calculate this thing. And by the way, we know we're working with a confidence interval. So we're going to go stat, arrow over to test, and it happens to be a Z interval, so that's number 7. So we're going to drop down to 7. So it's a Z interval for means. We have statistics. We're not inputting a list of data. We're going to go ahead and input our standard deviation, which is 10.2. Our X bar is 29.4. And then our sample size is 41. And we want a confidence level of 0.96. So this tells us between 26 hours and 32 hours. So 26.128 hours and 32.672 hours. And we were basically running a one sample Z interval for means, where this was my lower and this is my upper. And we want to go ahead and define the parameter. Because we're working for means, we know we're looking for mu. All right. So we're going to say let mu equal the true population mean time until parent sore throat symptoms improved, or until they're able to swallow comfortably. All right. Hope that helps you. Look forward to seeing you on the next one. Thanks for watching.